All right, guys, so I'm going to go over these slides with you. This way, if we lose service or I'm lagging, you still get the information. So I'm going to start out with slide 3. If you guys can go here, I'm going to give you a second. Okay, so you need to know from this slide that weather changes daily and climate is our average year to year. So climate is year to year and weather is daily. So like weather, it could be storming today, sunny tomorrow, raining the next day again, sunny. Climate, we know that every winter it's going to be cold. We know every summer is going to be hot. And then you have to answer the question here that says, what is the big difference between weather and climate? Then come here. So weather and climate depend on the transfer of thermal energy. We talked about thermal as being heat. So it's a transfer of heat and water coming in and out of the atmosphere, done through the sun and the water cycle. Temperature changes are because of the water cycle. It could come down when it condenses and it comes down and it precipitates. It could precipitate rain or snow. And then the temperature is also affected by the latitude, which is how far you are from the equator, north and south. Altitude is how high you are. So say from the bottom to the top of a mountain that you're increasing, you're going higher in your altitude. Temperature is also affected for how far you are from water. The closer you are to water, the colder it is. The farther away you are, the warmer it is. And ocean currents. So latitude, areas near the equator are warmer because they get direct sunlight from the sun. They're getting the direct rays. So they are warmer. As we go farther away from the latitude, it's going to get colder and colder and colder, especially when we get towards the north and the south poles. And it says, why is it warmer near the equator? Well, the sun's rays hit right there. That is why. Now, there's 3 different temperature zones we're going to talk about. The tropical zone, which is the ones closest to the equator. The temperate zone, which you get farther away from the equator. That's where we live, is a temperate. So the temperate means it's warm in the summer and cold in the winter. Tropical is warm year-round. Temperate is warm in the summer and cold in the winter. Then polar is cold year-round. Then you're going to come in here and you're going to type in those 3 climate zones we just talked about. And you're going to go to this slide. Altitude. I told you that's how high you are. So if you're looking at this picture down here, you're going to see it's green down here. It's grass. It's green. You're going to see up here where it's snowing. It's white. So the higher you go, the colder it gets because it gets less dense. Then you're going to come here. You're going to see this key, tropical zone, temperate, and polar. You're going to label them correctly down here. So I told you, here is tropical. I told you what we are. And you're going to put the same here as you would here. Then you're going to put the same here in this white area as you're going to put here. Then you're going to come here and answer these 1, 2, 3, and 4 questions. It's what is the difference between weather and climate? What does latitude measure? Not altitude, not the height from the ground. Latitude. Why is the tropical zone the warmest? And what temperature zone do we live in? Then you're going to come here. And the last thing that affects temperature is the distance from water. So when we stop outside, say it's cold at night, and we step outside in the morning when it just warms up, that ground could be hot because the sun's hitting it. It's going to heat up a lot quicker than the ocean is, or any kind of body of water. Water takes 5 times more slow to heat up than land. So you can go outside today and the ground be hot and the ocean could be cold. It's just so much more mass and so much more dense that it takes a lot longer to heat up or cool down. And then winds off the ocean prevent anywhere by the ocean to get really, really hot. That's why it's always cooler when we're by the ocean. It's that sea breeze where the cold air comes in and the warm air goes out. And then there's two different types of climates as well that we're going to talk about, marine and continental. So marine is a lot of the coastal regions, anything that's close to water. So like we are marine, we are close to the water. We are marine, which means it's mostly a warm winter and a cool summer. We don't get that cold. Then there's continental, which is extreme, where there's extreme hot and extreme cold. There's a big temperature difference. And then they're going to answer this question. How does distance of large bodies of water affect temperature of land? And the last thing that affects temperature is our ocean currents. So our marine climates are influenced by ocean currents and by surface winds and convection currents. That's what transfers our convection is what goes our heat, and our colds, how they move in the water. I'm going to talk about that more a little bit. So we talk about ocean currents. We talk a lot about Gulf Stream and the California current. The Gulf Stream is warm and it brings in warm water. It's all near the East Coast. It's by us. The Gulf Stream is by us and it brings in warm water. The California current brings in cold water, and that's over in the West Coast. So the West Coast gets cold water, East Coast gets warm water. And then there's a question here. What is the difference between California current and the Gulf Stream current? If you look at this picture, you're going to drag and drop these two boxes to where they go. See this warm water here? This is what I was talking about with the Gulf Stream. This is what I was talking about the California. So blue means cold, red means warm. Now there's three factors that affect precipitation. Precipitation is our rain, our snow, our hail, anything like that. And those are prevailing winds, mountain ranges, and seasonal winds. Prevailing winds always go in one direction. They're not all over their place. They're not going to go this way, that way. They're all going to go in one direction. And they move our air masses from one place to another. Now, the prevailing winds that we get here are called prevailing westerlies. They are coming from the west and they are going east. If you lived on the West Coast, you would get from the east to the west, which are prevailing easterlies. All right, so other factors that affect precipitation are our mountain ranges. So the mountain ranges have two different sides of them. There's a side that's beautiful, that's green, that you're going to actually see trees and grass on. Then there's a side that kind of looks like just blank rocks. Now, not only mountains have this, but our volcanoes have this too. The reason being is one side gets the wind and the rain, and the other side gets nothing. It's going to be completely dry. So the side that gets our rain and our snow is called our windward side because the wind's hitting it. Windward. The side that gets nothing is our leeward. So you need to know both sides. And what tells us which side is our windward and our leeward is not only by how it looks, but what side the prevailing winds hit. Does it hit the west or does it hit the east? Here's a better picture. This would be our windward and this would be our leeward. Now you're going to take these two and you're going to drag them to the correct spots. Come down to 18. There's seasonal winds. There's something called monsoons, which are our sea and our land breezes that change directions with the seasons. So we talked about our sea breezes. Sea breezes is cold air coming in, warm air going out. And our land breezes is our warm air coming in and our cold air coming out. So we have something that's called summer monsoons. That's when the wind blows inland from the ocean all summer. So it's a lot of rain. It's wind coming in from the ocean and rain. Winter monsoon are dry, but they go from the land to the ocean. It's a land breeze, even in the afternoon. So it's asking the difference. So you could talk about which one comes in from the water and which one comes in from the land. Then there's three more questions. Quick check. How are seasonal winds different from prevailing winds? How do winds affect precipitation? And how do mountains affect precipitation? So Vladimir Köppen developed a system to let us know about our climate, to classify our climate. And that's by looking at vegetation, which are different plants, and seeing what they look like, how they grow, how they look. And there's two things that affect how plants grow and affect how we classify climate. And that's our temperature and our precipitation, which we talked about the different ways those two are affected. We just talked about those. So it says climate is classified according to what two factors? Said that in the first part right here. Temperature and precipitation. Make sure you type that here. So if you look here, you have drag boxes. So when you do this, tropical rainy, you're going to go over to your Google Classroom. Or you could see it right here, tropical rainy. See this green? I'm going to take this box and move it here. Temperate marine. I already told you we are temperate marine, so you can drag that there. Temperate continentals, these purple areas. So you could drag it here, or you could drag it here. Dry would be right here. Our polar would be this white up here or this white down here. And our highlands are our mountains areas. So hold on, let me put dry back up here because that's where dry goes. And you can put our highlands right here. So highlands is down here and dry is up here. And this is where you go ahead and you place these. Let me put them back. All right. Now, tropical rainy climates, there's two different types. It's tropical wet and tropical wet and dry. Tropical are the ones by the equators. Remember, the tropical is by the equator. So tropical wet is a lot of afternoon thunderstorms, a lot of rain. It's hot year round, and it's a lot of heavy rain. Tropical wet and dry means there are dry times. It's hot and it's still wet, but it's not raining frequently all the time. There are dry times. So tropical wet, this would be over in like in Hawaii. Tropical wet and dry would be down at the bottom part of Florida. Then there's dry climates. There's two different types of dry climates. Dry climates get less rain than average. So there's arid and semi-arid. Semi-arid are on the outside of the desert. So it's still the desert, but it's very outside of the desert. And this is like in our Great Plains. And they get enough rain to grow small bushes like you see here. That's a semi-arid. They get enough rain to grow that. Arid does not get enough rain for that. That's parts of California and the Northwest. And the only thing that could survive there is cactus and yucca. It gets less than 25 centimeters of rain every year. That's a very tiny bit. It is a very dry area, mostly like a desert. You would see the desert with the sand. Then there's temperate marine climate, which is us. We are actually this first one right here, humid subtropical. That means we get wet and warm climates, and our summers have a lot more rain. When we go outside, we sweat. That's humidity. That is the water in the air. We're also subtropical. We get wet and warm climates. We don't get that warm of a summer, but we get a lot of rain during our summer. Then you have the marine west coast, which is Oregon and Washington. That's where winters are they're not very cold. They're very mild, but they're very rainy. It rains a lot there. And then the Mediterranean, which is California, it's mild and it's dry summers and then cool, rainy winters. It rains during the winter instead of the summer. So it says, what are the three types of temperate marine climates right here? Quick check, 27. What climate region includes semi-arid and arid? What climate region includes humid subtropical marine west coast and Mediterranean? And what are the tropical rainy climates like? Then 28. This is our polar climates, which is cold air. Very little moisture, very cold. And those things would be the tundra and the ice cap. The tundra are very short, still cool summers. They're still cold, but very bitterly cold winters. Everything is permanently frozen there. They can't grow anything except mosses. They can't even grow trees. Then you have the ice cap, which is always at or below freezing, freezing is 32 degrees Fahrenheit. So it's always at 32 degrees or below. It's covered in ice and snow And this counts Greenland and Antarctica in our poles. So this is our coldest regions. So it says, which climate is the coldest? Well, of course, the one that's always below freezing, the ice cap. Then you have the highlands. Highlands is mountains, high, high. It's telling you altitude, high. So you're looking at your mountains. This is all your mountain regions. They're colder than the regions around them. Of course, if you look here, it's green. As you go up, it gets white because of snow. The higher you go, the more subarctic it is, the more cold it is. And the reason being is because it's getting less dense. The higher we go, we learned, it gets colder. So it's the same thing in the highlands. What's the difference here? It says as you climb higher and climb lower in the mountains. 30. Temperate continental climate. This is not influenced by oceans, and they have very extremes in temperatures. There's two different types, humid continental and subarctic. Humid continentals, winters are very, very cold, and summers are very, very hot, and they have high humidity. And then subarctic, which summers are very short and cold, and winters are very long and bitterly, like Alaska and Canada. They have a very long winter and a very small summer. And it's not even really like a summer. It's still cold. So it says, do we live in the temperate continental or temperate marine zone? How do you know? Well, we're by the ocean. So would it be this? Think about that. This is nowhere near an ocean. 31. What region is cold because of its high altitude? What are the characteristics of temperate continental climates? And does the polar region get a lot of snow? Why or why not? And you're going to answer these two questions before we continue, which is, what do you know about climate changes in Earth's past? And how do you think climate changes might have affected plants and animals? So when we're studying ancient climates, we need to look at Greenland. Greenland, you would think is green, and you would think Iceland was ice. Actually, Greenland was actually a tropical area back then. This is kind of what it looked like. It looked beautiful. It was warm. It was tropical. It was warm, moist. It was humid. Now it's actually covered by 80% of ice from the ice cap. Now, how do we know that? Well, we got to look at a couple things. We need to look at ice cores to know that, because it's covered in ice. So that would tell us. And trees that are there. So ice caps, I'm going to talk about that on the next slide. And why is this important? It's because it tells us plants or animals need certain conditions to live. So similar plants and animals in the past also require those same conditions. So as conditions change, so do the plants and animals there. So the ways to study ancient climates is, one is looking at pollen. Each plant has an old type of pollen. Now, science could take a drill to the bottom of a lake, because the bottom of the lake will be there for centuries, years, and take pollen samples, and then be able to go ahead and identify what has lived there in the past. And that will tell us what the climate was in the past, depending on what lived there. Because like we said before, only certain animals and plants could survive in certain climate conditions. The next thing we can look at is tree rings. Each layer of this tree ring is a new year. So they form a new year, and they also go ahead, depending on how wide or small that layer is, they could tell us if they had a great growing season with a lot of rain, or if it was dry, or if it was ever on fire. So the wide rings, they tell us it was a lot of rain. It was a great growing season, the wide rings in that tree. The narrow ones tell us it's a short season. It was very dry. It was very cold. So they look at the tree rings and they count them, and they'll tell you how old that tree is. Then there's ice cores, which is what they looked at for Greenland. Ice has a layer for each year, like trees do. And they can look at the thickness of the layers, and it tells them what was trapped in the layers, what was there for that time being as well. So it says, how can you tell and how old a tree or a piece of ice is? What else can you tell us about these? What else can those things tell us? Then we have 4 factors that change climate. One is, we used to be part of one continent called Pangaea right here. See it right here? Pangea is right here. And then everything shifted over time the countries broke apart. And I mean, the continents broke apart and they ended up where they are located now. And that also changed the climate, the wind, and the ocean. It changed everything when they broke apart and moved. And then it also changed with the position of Earth relative to the sun. When Earth's orbit is more elliptical means there's less, and then that means there's less sunlight that reaches the Earth. During the Ice Age, it's when our climate was all over cooler and our land was all covered by glaciers. And what affects this and what makes it more elliptical or not is how our Earth is tilted and the direction that it moves in. So that affects the severity of whether it be an ice age or what's going on in our current climate and weather. Another one is volcano eruptions. When volcanoes erupt, they release huge amounts of ash and aerosols. So aerosols is chemicals, ash is that brown stuff that you can get in your finger, you can feel on your fingers and see come down into our atmosphere. We've already talked about the layers of the atmosphere up into there. Aerosols are solid particles or liquid drops in gas. They are gases. Aerosols can stay in our atmosphere for months and years. And it could actually reflect some of our solar radiation and cool down, because if it reflects it, it hits it, it goes back out, the sun, which would make everything cooler around it for years. So it lowers temperatures worldwide. The last one is changes in the sun's energy output. Output is what the sun puts out. So short-term changes in climate are caused by the amount of energy the sun lets off. The changes happens every 11 years. So every 11 years it changes. And then sunspots, which you see on this little sun, those dark areas, they increase when the sun gives off more light. And we could do that and use those to measure our solar energy. And then answer this question down here. What are the 4 factors that change climate? Our carbon footprint is how much we have affected our Earth, on our climate, in our atmosphere. About how many greenhouse gases we gave off, either directly or indirectly, into our atmosphere. Our greenhouse gas is the atmosphere is what protects us from the cold of space. It insulates us. It keeps us warm. Otherwise, we'd freeze and turn into a giant ice thing immediately. So when the sun warms Earth's surface, it hits it, and then it radiates back as infrared waves to us. And infrared can pass through nitrogen and oxygen. Now, greenhouse gases are our water vapor, our carbon dioxide, our methane, and other gases that actually get absorbed into our atmosphere, and it makes it harder for our atmosphere to reflect the cold of space. And it's trapping that heat into us. So our Earth's getting hotter, but it's also breaking down that layer that we have to protect us from the cold of space. So if there are too many greenhouse gases, it could be extremely dangerous for us. And we're increasing our gases every single day. Carbon dioxide is the most abundant, biggest gas that we have. And it actually comes from burning fossil fuels, which is from natural gas, any type of gas that we have, or any type of coal forms that fossil fuel. Methane is also what's coming into us, and that's from raising animals like you see here, farming, landfills, mining, processing things. All of that is doubling the amount of methane we have in our atmosphere. Now, the effect is that our temperature has raised gradually in small increments over the last 120 years. It's called global warming that's happening. And the greenhouse gases are creating that global rise in temperatures. Now, our climate models are predicting global temperatures will rise several degrees over the next 100 years. So it's going to keep getting warmer and warmer and warmer. Now, over the past 800 years, global temperatures have gone up and gone down. Global warming is part of a larger set of changes to our Earth's climate, and together that's called climate change. So the effects of global warming include our glaciers melting, rising sea levels, drought, desertification, which means it takes places that were beautiful and green and turns them to a desert, changes to our biosphere, which is our protective layer around us in our atmosphere, and temperature changes. You can see it right here. Look at the before and after picture. It's melting. And then the also effects, I said, are melting glaciers, rising sea levels, because when the glaciers rise, melt, the sea levels rise. They have to go somewhere. And so any coastal areas could become permanently flooded. You can hear things are under sea level. And then droughts and desertification. Rising temperatures can lead to water shortages and droughts. Droughts can cause some places to become deserts. And that's desertification, lead to food shortages, change a beautiful green area to not a green area. And then biosphere changes. As temperatures rise, organisms will travel someplace more familiar climate. So other animals that are there that can't survive in that climate will become extinct. It says here, what are the effects of global warming? You're going to answer that question. Then you're going to, how we limit it. We're going to find clean, renewable sources, like clean energy. We're going to find things as solar, wind, hydroelectric, geothermal, nuclear, tidal energy. Anything that's renewable that doesn't use a gas or something that's going to hurt our atmosphere. And then we need to be more energy efficient. We need to stop wasting energy. You always hear energy efficient products. Those things are better than any other product because it uses less energy. You could start walking or riding a bike instead of riding a car. And then removing carbon from fossil fuels. Technology is actually being developed right now to remove that carbon dioxide from fossil fuel and bury it underground. The only downside is it's really expensive. People don't want to spend money, and it takes more energy. Then you're going to answer, what are greenhouse gases? What is causing global temperatures to rise? And what are some ways to limit global warming? Make sure you're checking out the videos that I have on Google Classroom. You are filling out these questions. And if you have any questions, please let me know. And make sure you're filling out your digital notebook.